Problem 2. The speed of the ship in still water is 9 kilometers per hour. Traveling from one end of the river to the other end and back, the amount of time spent traveling downstream to the amount of time spent traveling upstream is 1 to 2. Today, the speed of the river current doubled than usual because of the unusual thunderstorm weather. And traveling from the first end to the other and back took a total of 10 hours. So we're being asked, what is the length of the entire river? So first we have scenario 1, which is when there is no thunderstorm and the water is normal. So the speed of going downstream to the speed of going upstream, we know is 2 to 1. And now let's do just two things first before continuing. First, you might see that I'm not doing 2 to 1 like this, but instead I'm writing it as a fraction form. That makes it easier to work with and calculate when I need to. And if it says that the amount of time spent downstream, that's the amount of time. So if I said T is for time, D over T U, which is upstream, that would be 1 and 2. But since the downstream speed is faster, that's why it takes less time. So that's just kind of flipped around. Okay, this is the relationship between time and speed. So you should get to know that, so you're not confused. So we know that, there's a water speed, and water speeds don't change. Well, they do, but in each scenario, they don't change. So the downstream speed would be 9 plus the water speed, the velocity of the water. And the upstream speed would be 9 minus the velocity of the water. And, well, what value could the velocity of the water be if you want the final ratio to be 2 to 1? Well, then this would be 3, and it takes a couple of tries. That's okay. So if 3 is equal to the water speed, then 3 doubled would be 6 kilometers per hour. 6 kilometers per hour. If it took a total of 10 hours, what is the length of the entire river? Well, the shape of the speed is still 9 kilometers per hour, so that would not change. So the velocity of downstream speed to the velocity of the velocity of going upstream in this scenario would be 9 plus 6 to 9 minus 6, and that's 5 to 1, meaning that their time ratio, so the time it took to go downstream versus the time it took to go upstream would be equal to 1 to 5. So if we have this, we know that there is a total of 6 units, right? 1 plus 5 is 6. So 10, the total amount of hours divided by 6 gives us 5 over 3. So this is how many hours it took to go downstream, meaning that the entire journey was 15 times 5/3, which is equal to 25 kilometers. So the final answer is 25 kilometers.